Human dynamics is about doing models around social behavior to do analytics. We are also doing, this is sort of user interface and consumer electronics, so this is kind of like augmented reality and 3D interfaces and holography. We do a lot with robots, especially social robots that teach. We're doing synthetic neurobiology, so this is Ed Boyden, who was a graduate of the Media Lab, and he went to get a PhD in molecular biology at Stanford, because we didn't have biology at the Media Lab at the time. And he said, I'll be right back. He comes back and he connects a wet lab to the Media Lab. And what he was able to do is he was able to identify the gene sequence in algae that was photosensitive, transfer it into a virus so that you could then send it and inject it and create little photosensitive nodules on nerves. And then he was able to make these optical fibers so that you can write information into brains and also read information from brains. So now we've got an interface that allows humans to control things directly from their brain. And we've learned a lot about the brain. The other neat thing about it is we were also have been able to solve blindness in mice, because it turns out there's genetic blindness where people don't have the cones and rods, but they have the nerves there, and by creating these nodules on the nerves, the mice are able to see shapes and things like that, and so we're going to be doing human trials, I think, in about 18 months. So when we say media, we mean all kinds of things, including gene sequences. Tangible media is kind of the relationship between bits and things. Virtual spaces is trying to get information out into the real world. Biomechatronics is kind of interesting. This is a professor named Hugh Herr who lost both legs in a mountain climbing accident, and he's creating robotic prosthesis. And so this is Professor Hugh Herr. But it's interesting because it is multidisciplinary, because we bring in people who understand locomotion, who understand robotics, who understand interfaces, because the legs, when you have prosthesis, your legs have to know where they are in your gait, and to be able to assist. And the design constraint for this is they want to create prosthesis where the amount of energy that's required to walk is no more than walking with normal, with normal legs. And as you can see, he has almost no noticeable movement for gait. Idea is to get rid of crutches because they're horrible and they're. He has a handicap sticker on his car. He often gets stopped by the police when he's running to a meeting from his car. We also do things like opera with robots and musical instruments. And we have another group working on sensors. This is Media Lab with all of its sensors visualized. We're doing things in sort of the future of information and interfaces with information. Lifelong Kindergarten is a very important group. This comes from the lineage of Seymour Papert. And so they're the ones that made like the Mindstorms, Lego Mindstorms. They created a programming language for kids called Scratch. So there's like 3 million projects that have been uploaded using Creative Commons licenses to allow people to share and build on each other. If you have kids, you should definitely check out Scratch, because it really is a great way to teach kids how to program. Effective computing, originally a lot of this work was done for helping kids with autism understand their surroundings and also to measure their response to things. And they created these skin conductivity things to sort of be able to understand how these kids were feeling. And they also created ways to look at the facial expression of the people around them so that kids understand how people were feeling. It turns out this is really useful for marketing too. So now we have, we can show videos on the internet and we can see how people are reacting to them. We can also put these sensors on people to see how they're reacting to environments and change them. Changing places, this is a lot of urban development. It's kind of like architecture and urban development plus geeks. And so, we work on building electric vehicles and interfaces. We have a city car project to try to improve, for instance, parking density by creating cars that sort of, here's a city car. So each of these wheels is a little robot. then, and again, this is very multidisciplinary. So we're working on the electric vehicle part of it, the charging, the architecture around how you put the building together, and kind of the urban planning of what would it look like if you had these city cars in cities. We're actually starting to work on the deployment of them. Then we're working on bicycles, electric bicycles. These are to go into bike lanes in Europe so that people who have handicapped disabilities or are wearing long dresses can still be in the bike lane. There's also an interesting problem with these bike rental systems where you end up with lots of inventory in one place, and they use these trucks to move bicycles back and forth between parking lots, which is kind of stupid if you think about the fact that we're trying to save energy. So one of our students decided that by changing the pricing mechanism about the rentals, you can get paths to people to behave differently so that you can flatten out the inventory. You don't have to truck the bicycles around. So we created a mobile app that does that. So again, this is important because when you add geeks to the mix, suddenly things that aren't very obvious to urban planners or architects suddenly become very interesting. And then we have a group that's working on the future of civic media and civic action. But anyway, that's kind of a whirlwind tour of some of the projects. We have about 350 of these projects. And so you can kind of imagine that when we say media and Media Lab, we mean a lot of things. And here's how you can reach me. But that's the end of my talk, and then we'll be going to Q&A.